Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the LeetCode problem again and again for the daily habit, and index is 729 and the problem is of medium type problem of the LeetCode. Okay, so I've thought something interesting that before moving to discuss this problem I just want to show you something interesting, and it is this one. Thank you for your love and support. That is, currently we have reached the thousands of subscribers and currently it is like incrementing by a huge amount. And thank you for your love and support since you have liked our content and subscribed it and share it among your friends. Again, I'm asking you that if you love our content, if you have any doubts regarding any of our videos or any of our things, just mention in the comment section of the video. We will try to update ourselves and we'll try to help you guys in all possible ways. And also I will just ask you that if you love our content and all that stuff, then you should must have to recommend to your friends so that it can help them out also, and you can share it and help us by subscribing our channels, and that's all. Okay, so talking about this problem, implement a my calendar class to store your events. A new event can be added if adding the event will not cause a double booking. Okay, so what is the event? I think start to end, like it is actually a range of dates, I think. Yes, so we will have to implement the method book. This one formally, this represents a booking on the half open interval. You can see the start time has a inclusive bracket while the end time doesn't have some inclusive bracket. Okay, so rather than focusing on this one, let's move further. Double booking happens when the two events have some non-empty intersection, that is there is some time that is common to both the events. Okay, for each call to the method my calendar book, return true if the event can be added to the calendar successfully. That is, if you try to add my current event to the calendar and if there exists some another event which is going to make an overlap with my current event, I cannot add my current event, right? Okay, otherwise return false, do not add the event to the calendar. Okay, so here are some series of examples I will discuss over that. I don't think this example is sufficient. I will take some my own example. I will try to explain in the best possible way, and there's a note also. This is at most 1000 and this is this one. Okay, so we'll try to make it something like really cooler code. Okay, like it is actually much interesting. You can see the constraints like start and it can vary up to 0 to 10 pound, and it may cause a trouble to us. And what is that trouble? Suppose it is like up to 10 power 5, then you can maintain an array, I think, and it can be done easily. But here is something like interesting, 10 power 9, you cannot maintain an array of size 10 power 9. That is a boolean array, it may help us, but here it is not going to help us and it is causing some trouble. Okay, we will manage that. Okay, so let's move further to understand this problem in the with the help of examples and learn the concept, and we'll try to implement that also. Okay, so let me give it a like over here because we are going to learn some new concepts. So let's move further. Okay, so this is stuff that I have made over here. Okay, so it is basically asking that suppose we have some intervals like called, let's say, 5 to 7, and it's open and here is some close. It means that we have some okay, so let me make a line over here like using this one. Okay, so it is a line, and what I'm going to do here, it is 5 and somewhere 6 around and somewhere 7. Okay, it means that this is included, but this is not included. Okay, so this is one of the intervals. Suppose this has been given to us, you are just going to take into account. Suppose another interval comes over here and it comes like 7 to 9. Can this interval be taken with this interval or not? You must have to check it out. And what is the method of doing that? Just try to make a line also. Okay, let's try to do that. So note that this point is not included due to this because there is an open bracket. Okay, so let's try to do that. If I will try to increment this line up to this 9, and there is somewhere 8, and this is included. Can this is included in our answer or not? Note that 7 is not included by this interval, so I can include this one. Okay, so now this is included. Yes, I can take 5 comma 7 and I can take 7 comma 9. Okay, okay, so let's try to take another interval. And what is that another interval? So let's suppose I am going to take like 4 to 6. Can I take this interval? Let's try to understand that. Let's try to extend this one up to this one. I'm going to say yes, there it is 4. I can take 4. So I will try to take 5 now. Note that 5 is already taken. So I cannot take 5. So I should have to return my answer as false when this interval is given to us. And this will return true and this will return true. Note that there is a sequence of operation being done. Like first this will be done, then second this will be done, then this will be done. So if I will follow a sequence of operations like this will be done first, then this will be done, this will return true, this will return true, but this will return false. Okay, so this should be cared of. Like how you can implement this entire scenario. Let us try to understand that again. Like suppose we have some interval. Okay, this is not a straight line, I guess. So I will take some straight line to have a better feel over this question. So okay, so this is some straight line. Then I will take some color, another color. What I'm going to do is suppose this is 5 and this is 6 and this is 7 and this is 8. And suppose we have been given some interval 5 to 9. Okay, and this is included, this is included, this is included, and this is included. I'm not taking 9 over here. Okay, now the advantage when that is the start and end, you can see S and E is going to vary up to 10 power 9, right? And it is like greater than or equal to what? 0. Okay. 0. Okay, now suppose it is not 10 power 9, it is like 10 power 5. Let's suppose for a while. Then what you are going to do is suppose you are going to maintain an array, Boolean array of 10 power 5 size, I guess. And when you have encountered this interval 5 to 9 or 5 to something, you all mark this positions as what? True, right? That is, these positions have already been included into your calendar. Okay, and whenever you encounter another interval and when you try to mark these positions back into this range of the array, then you will find that at a certain position, if you find that the value at that position is already true, it means that that position has been already included into your calendar. And then this raises a contradiction. You're not going to add this event to this calendar. Then what you are going to do? You are going to return false, denoting that this current event cannot be added to your answer. And otherwise, if you can add these positions, that is, if you are able to mark all the positions which are already false, and you are going to make it true now under these positions, let's say S1 to E1, you can easily claim that yes, this event can be added to your answer. Okay, this is the very brute force approach. And brute force approach you can also say like when it is 10 power 5, but I want to deal with 10 power 9. How we can do that? Okay, so let's move further. So what I'm going to do is suppose let's take a line, and it is like again 5, 6, 7, and then 8. Okay, now what I'm going to do is you can insert the elements into your let's maintain some set, or you can also say you can insert the start positions and end positions into some vector or some array. What I'm going to do is let's try to understand that. Okay, you can see what I'm going to do is if my position, let's say I've been given some 5 comma 9. Okay, and I will insert the value corresponding to 5 with 1, and I will also insert the value corresponding to this 9 as -1. Note that 9 is not included in our current interval. It has an opening bracket. And doing this, what is the advantage of doing this? Right? You must be wondering that. Okay, so what I've done is, let me recall it. Like whenever I will encounter some start position or some end position, I will push the pair start comma 1, that is the value corresponding to start is 1 and the value corresponding to the end position is -1 to my let's say let we are maintaining a multiset. And what is that multiset doing? It is actually basically a set with multiple same values. You can also take a like set, but I am here taking multiset, it's my choice. Okay, so I will take a multiset. And what is this multiset doing over here? Multiset will store the pairs, that is this one and this one, for every entry that we have been given in this question. Okay, so corresponding to the start position, I will push up this one value, and corresponding to this end position, I will push up the -1 value. Okay, so my multiset will store the values in ascending order with the help of first element of the pair, then to the second element of the pair. Okay, so my values will come up to 5 comma 1 will be at the top of the multiset. Then again 9 comma minus 1 will be again at the top of the multiset. Now suppose another pair comes up. Like what is that another pair? Like let's say another pair comes up is 9 comma 11. 9 has the closing and 11 has the opening. Again what I'm going to do is I'm going to push up the element 9, and what is the value corresponding to this start position is 1, and what is the value corresponding to this end position is minus 1. Okay, then I will push up this 9 and 11. So 9 will hold the value as 1 and 11 will hold the value as minus 1. Okay, so you can easily observe that this is the correct order that is present in this multiset, right? And you must be wondering that why I am pushing this 1 with start, that is I am appending this value 1 with the start, why not minus 1 with the start and end with 1? And the reason is very simple. You can observe here this example, like this example, because here I am maintaining the multiset. It will store the start comma end, that is start comma the key, and if I will store the start as minus 1, okay, and end as 1, okay, I will write as minus 1 and end as 1, you can see this will come up first and this will not come up at the second. It will come up as 9 comma 1 and it will come up as 9 comma minus 1. But if you follow the sequence of operation, it means that 5 comma 1 event has been started and it is being end first, that is 9 comma minus 1 should come up the first, because this event is going to be ended before the another event is going to be started. That's why multiset will store the values in like on the basis of first element, that is ascending order of the first element of the pair. Then it will sort on the basis of ascending order of the second element of the pair. Okay, right? So it will first sort on the first element of the pair, like that is 9 and 9. You can see the elements are seen. Then it will sort on the basis of second element of the pair, that is minus 1 will come first. Okay, that's why I have just sorted on the basis of start corresponding has the key as 1, end corresponding has the key as minus 1. Okay, so this will hold the correct value, like 9 comma minus 1 will come like before this 9 comma 1. It means that 5 comma 1 event has started and it has ended before the starting of another event, like this 9 comma 1 is going to be started. Okay, now there are some sequence of events. Okay, so let me take another page and explain you a little bit faster. Like 5 comma 1, and then it will have this 9 comma minus 1. Note that it is like a pair in this multiset. Then again 9 comma 1, then 11 comma minus 1. And suppose you have another pair, like let's say okay, so I'm just writing it out as 4 comma then 5. Okay, if this element is going to be inserted in the multiset, what will happen? 4 will have the corresponding value as 1, and then 5 will have corresponding value of minus 1, and then 9 will have corresponding value of okay, so I'm writing now as fast, 5 as 1 and then 9 as minus 1 and then 9 as 1, then 11 as minus 1. Okay, you can see that when this element is going to be started, that is 4, event 4 is started and ended at 5, the sum is coming out to be like, when the sum is coming out to be 1, then again sum is coming out to be 0, like I'm going to write it as 1, then sum 0, then again sum is coming out to be 1 and sum is coming out to be 0, and again the sum is coming out to be 1 and sum is coming out to be 0. Note that I'm talking about the prefix sum of the elements present in the multiset in ascending order, right? And how this will help us in finding out the answer. Okay, so whenever some element, some segment is going to overlap with some another segment, the prefix sum becomes greater than 1. And when the prefix sum becomes greater than 1, I can claim that yes, there is a segment overlapping with that. Okay, so if you're not understanding this right now, no need to worry about. Let's say I'm going to append another element, and what is that another element? Let's say I'm going to insert another interval starting with 3 and ending at 5. Okay, ending at 5. Then what will happen? This element will be inserted in this multiset, so it will be inserted at the top. So 3 will have the value okay, so let me erase this first. Okay, okay, so 3 will have the value as 1 and 5 will have the value of as minus 1. Okay, so what will happen if you insert this in multiset? 3 corresponding to 1 will come first, then you can see 4 corresponding to 1 will come first, because this has the value 5, then 4 corresponding to 1, corresponding value is 1 come first, then 5 corresponding value has minus 1, then 5 corresponding value of minus 1, and so on. But if you maintain a prefix sum, it means that there is a one event, one started, but it has not been ended, and another event has also been started. If you take the prefix sum will come out to be greater than 1, and it signifies that, there is some segment that is being overlapping. Okay, so you have to return false, otherwise if this everything goes right, then you have to return true and insert that element into this multiset. Okay, so I think this have the complexity not good, and you can see it has the runtime as 420 ms, and the time complexity goes like O of n square. What I'm going to do, maintaining a multiset and inserting this one, start and end, and this is the running prefix sum, and take start iterating in this multiset, and if it is positive, increment your running, otherwise decrement your running, and if running whenever becomes greater than 1, I need to erase that entry from this multiset and return false, otherwise return true. Okay, this is one of the methods, but I don't think that is a cooler method. Okay, this method is like making your concept very much clear. So I have just tried to understand this another method which I have been implemented by optimizing that code. And what is that another method? Let us try to understand that. Okay, so another method is like pretty much simple. What I am going to do is like pushing up the pairs directly, start comma end, into this set. And how this is going to help us? Okay, so we have some certain element of the pairs like S1 E1, S2 E2, and S3 E3, and some S4 E4. Let's say these elements are already present in this multiset, or not the multiset now. It is actually I'm maintaining the set, and it is already present in the set, and all are the valid. No one no two pairs is going to overlap with each other. Okay. Now, if this is present in the set, it means that S1 is already going to be like less than S2, and S2 is already going to be like less than S3, and all are this go like sorted in ascending order, right? So now what I'm going to do is like suppose we have found another element pair like S, so let's say Sx and Ex. Okay, now if I will have the Sx and Ex as the pair, then what I'm going to do is find the lower bound in this set. And why this lower bound is going to help us? The lower bound is going to help us like in just checking it out if this element can be inserted into its correct position in this multiset or not. Okay, so what I'm going to do is suppose this S1 E1 comes over here, then S2 E2 comes over here, and now suppose this Sx and Ex is that is this pair is correct position is over here, let's suppose, and then comes S3 E3 and so on. Like suppose this has this Sx Ex, the correct position of this Sx Ex is over here. Now let's check it out if this is the correct position of this Sx Ex or not. Okay, and suppose lower bound is pointing at this iterator, like you know the concept of lower bound, like suppose we have the elements like 3 3 3 5 5, and if you find out the lower bound of this 5, then it will point out to this position. Okay, so I'm trying to just find out whether this position is the correct position in this set or not. Okay, so this will be correct position only and only when the next element of the pair, if present, will hold the criteria of this non-overlapping condition. And what is that non-overlapping condition? You can see the Ex. Okay, so I'm just pointing it out with another thing. You can see the Ex and S3 must hold some relation, right? And this E2, if there is some backward element, the backward pair present, then E2 and Sx must also hold some relation. And what is that relation? Okay, because this is the E2 of the ending time of the previous event. If we have some series of sequence of events, then you must have to write some condition. What is that condition? That is Sx. Okay, okay, so you must write down this one. If E2 is going to be like greater than Sx, or this if E2 is greater than Sx or Ex is greater than S3, right? if any of these two values is coming out to be true, like this is the boolean result, let's say bool 1, and this is the bool 2, this is the boolean result, and this is also the boolean result. If e2 is greater than sx, it means that these two values are overlapping, because this s2 e2 is another event which has not ended, but this event has already started. And similarly sx ex and s3 e3, it means that sx ex is not yet finished and s3 e3 has started. Then I can say this sx ex cannot be inserted into my current sequence of events. Otherwise we can insert that. So we need to check these two conditions by taking the lower bound. Okay, so let's move further to understand this with the help of coding part. Okay, you can see I've already submitted some code. Like I maintained the set pair s, and this is actually maintaining the pairs. Check if the current time interval can be inserted or not. Find the lower bound to find out the correct position, and if my next element exists and this end is greater than itr dot first, that is the current ex, you can see, is greater than itr dot first, that is the next element, starting value, starting time itr dot first, then I can say return false, current element cannot be inserted. Also I need to check with the previous ones also. If a previous one exists and this previous value, that is, note that I'm decrementing this iterator by 1, previous value second, that is previous ending value, you can see e2 is greater than my current start value, then I can also return false, because this element cannot be inserted. Otherwise insert it and return true. So this is all about this sequence of questions. Like, okay, so you can see it has a runtime of 124 and 389.9 MB, and it's like good one. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to YouTube channel for latest updates. Thank you for watching this video.